which does say if the internal bisectors are congruent, meaning AE equals CD, then the triangle's isosceles. So this proof is by contradiction. So what we're going to assume that the triangle is not isosceles. So if that's true, then angle A and angle C are not going to be equal, because if they were equal, then it'd be isosceles. Now, without loss of generality, which is this WOLOG abbreviation here, we suppose that A is less than C. Angle A is less than angle C. I put I showed put ones here and twos here. We bisect, those are the angle bisectors. So angle one is less than angle two, because halves of unequals are unequal in the same order there. And now we want to find point F on bisector AE. Remember, 1 is less than 2 there. Angle 1 is less than angle 2. Since angle 1 is less than angle 2, we can make a copy of angle 1 inside, in the interior of angle DCE. We can make a copy of angle 1. All right? So we find F here. That's between, F is between A and E. And this is going to be angle 1. Now, F can't be on the other side of CD, because 2 is bigger than 1. So now we did draw a CF there. So we have that this quadrilateral ADFC Yeah, I did mess this up. What we really have to have here is here's 2. We want to find F, so that ACF is going to be angle 1. Okay. So ACF is your angle 1. Now we can say that we have ADFC, and these two angle 1s here meet the conditions of lemma 1. Okay, this is a 1 here. That means that we can draw a circle through ADFC, that there exists a circle through ADFC So I'll try to draw the circle through ADFC. There's your circle through ADFC. Because the angle one, and angle one, those two angle ones are in the right spots. So what we want to do here now is we want to prove that that ACF and angle A are both acute, so that we can apply lemma 2. We know that angle A is half of angle A plus angle A, because angle A plus angle A is 2 angle A. But we know that we have assumed that A is less than C, so this is going to be less than half of A plus C. Now that's less than half of A plus B plus C, because B is positive, has positive measure. But A plus B plus C is 180, and half of 180 is 90. So now we have that angle A is less than 90, so angle A is acute. And if we look here, we can rename this this expression. We can give it another name. It's equal to half of A plus half of C is really half of A is 1 and half of C is 2. So half of A plus half of C is going to be equal to angle 1 plus angle 2. That angle 2 is half of C, angle 1 is half of A. But 1 plus 2 is also called ACF. This is also angle 1 plus angle 2 is going to be ACF here. That's angle 1 plus angle 2 is ACF. So ACF is less than 90 also. So these two angles are acute. That means, okay, that we have that angle A is going to be less than ACF, because angle A is 1 plus 1 and angle ACF is 1 plus 2. So that means that the intercepted arcs, those are inscribed in the circle. So the intercepted arcs have the same order of inequality, meaning that CD is less than AF. That's by lemma 2. Lemma 2 says that the subtended chords are have the same order of inequality as the size of the acute angles. But AF is less than AFE, which goes all the way out to the triangle. But AFE is AE. So we have that CD is less than AE, but that's a contradiction. Those are the angle bisectors, AE and CD. So that means that the assumption is false. and ABC is isosceles. Now, another thing that we recognize is that this is extra base angles of an isosceles triangle are acute, all isosceles triangles. And we can see that because we can see that angle A plus angle C is less than 180 or less than pi, less than 180 degrees. And angle A and is equal to angle C. So these together say that both A and C are less than 90 degrees. The reason A plus C are less than 180 is you have to have something for B. So that's the end of this, and hopefully you can understand my blunders and also the proofs.